Welcome to the unit on algebraic expressions, manipulating indices. The objectives for this session are to understand that the laws of indices can be linked with any rational power and manipulate these laws. Namely, a to the power 1 over n is the nth root of a to the power m over n is a to the power m nth rooted, a to the power minus n is 1 over a to the n, and a to the power 0 equals 1. Of course, in some of these circumstances, we cannot consider a equal to 0. Indices can be negative or fractional numbers. So, for example, the value 1 over 3 is an index in the following expression. This simplifies to x to the power a third plus a third plus a third. And of course, this equals x to the power 1, which equals x. Similarly, the value 1 over n is an index in the following expression. X to the 1 over n times, multiplied by one another. This equals x to the power 1 over n added n times, which equals x to the power 1, which is of course x. The laws of indices can be linked with any rational power. The key laws have been highlighted on your screen. Let's take a look at some notation. A number is rational if it can be written as a over b, where a and b are integers. Remember that integers are whole numbers. They could be positive or negative. Now, a to the power 1 over 2 is the positive square root of a and is denoted as shown on your screen. So, for example, 25 to the power 1 over 2 equals the square root of 25, which equals 5. However, 25 to the power 1 over 2 is not equal to minus 5. Now let's simplify x to the power 5 divided by x to the minus 3. We can convert the denominator into a numerator by multiplying the index by minus, as shown. So we have x to the 5 minus minus 3. Of course, 5 minus minus 3 is 5 plus 3, and this equals x to the power 8. Now for example 4. Simplify x to the power 1 over 3 times x to the power 5 over 3. We can simply add the indices as the base is the same. So we have x to the 1/3 plus 5/3, which equals x to the 6 over 3, which is of course equal to x to the power 2. Now for example 5, simplify x to the power 5 all raised to the power 3 over 5. We can multiply 5 by 3 over 5 to give us x to the power 3. And now for example 6, simplify the expression shown. So let's rearrange so that we can see the numbers as a fraction, 3 over 7 as shown, and then proceed to deal with the indices of the common base. So as we're dividing, we need to subtract the indices. So 2.5 minus 0.75. And that of course equals 2.5 plus 0.75, which is equal to x to the power 3.25. Now let's simplify the expression shown. We can raise the contents of the cube root to 1 over 3. So now we have 8 to the power 1/3 times x to the 12 to the power 1/3. And of course tidying up. And here we can multiply the powers and tidy up some more. And of course x to the 12 times 1 over 3 is x to the 4. Which gives us a nice neat solution of 2x to the power 4. Now for example 8, simplify the expression shown. Now split up the fractions. So 3x to the 4 over x to the 7 minus x squared over x to the 7. Next, tidy up the indices. So we have 4 minus 7 in one and 2 minus 7 in the other, to give us 3x to the minus 3 minus x to the power minus 5. And we can rewrite this as 3 over x to the 3 minus 1 over x to the 5. Now for example 9, evaluate 16 to the power 1/2. We can rewrite this as the square root of 16, which equals plus 4. Now evaluate 125 raised to the power 1/3. This is the cube root of 125, which equals 5. And 81 to the power 3 over 2, which can be rewritten as the square root of 81 raised to the power 3, which equals 9 all cubed, which is 729. And now 9 to the power minus 5 over 2. So let's do this in parts and break it down. This is equivalent to 1 over 9 to the power 5 over 2. We've simply removed the minus sign and put the 9 to the 5 over 2 in the denominator. This is a square root of 9, all raised to the 5. So the square root of 9 is 3, and 3 to the power 5 is 243. So overall, 9 to the power minus 5 over 2 is 1 over 243. Now for example 13. Pause the video and have a go before proceeding. Press play when you are ready to view the solutions. So let's examine this example. We have that y equals 1 over 125 times x cubed, and we're required to express y to the power 1 over 3 in the form c times x to the power m, where c and m are constants. Now y to the 1/3 can be rewritten as shown. This gives us the expression on the screen. We've used the law ab to the power n equals a to the power n times b to the power n. We can simplify the constant first, so cube root of the whole expression, and in particular we're cube rooting 125. The cube root of 1 in the numerator is of course 1. And of course x cubed raised to the power 1 over 3, we simply multiply the powers to give x to the power 1, because 3 times a third is 1. And then we simplify in the next step 1 over the cube root of 125 to give us 1 over 5. So overall we have that y to the 1/3 is 1 over 5 times x. Now express 5y to the minus 1 in the form c times x to the power m, where c and m are constants. So again, if we're trying to simplify 5y to the minus 1, we replace y with the expression that was assigned to it, i.e. 1 over 125 times x cubed. So recall that ab to the power n is a to the n times b to the n, and this is the law we've applied here. We start to simplify now. 1 over 125 raised to the power minus 1 is of course flipped over, so we get 125. And then x cubed to the power minus 1, we simply multiply the powers, 3 times minus 1, and then tidy up 5 times 125, and of course leave x to the minus 3 as it is, giving us an overall expression of 625 times x to the minus 3. So this brings us to the end of this session. If you have understood its contents, you should be able to understand that the laws of indices can be linked with any rational power, and also manipulate the laws shown on your screen. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to it.